the depths of our oceans, to the heights of space, there are no limits to what we can accomplish when we push past our current boundaries. There is nothing more potent than the will to learn and to share what we know. The future is happening faster than you think. Curious about new tech trends? We're here to help you stay up to date with this fast-changing world. At each live talk, we will discuss different technologies and trends with global experts from countries around the world. Ask your own questions and learn how to get the answers you want to get on the forefront of technology with tech innovators.
Electric vehicle adoption is outperforming all expectations and is now expected to represent over half of U.S. vehicle sales by 2030.
The key link to mass adoption is now software, not hardware or vehicles. From $1 billion in 2021,
electric vehicle charging software is forecast to grow to $25 billion by 2030.
making it one of the fastest growing software sector in the market today, and a huge opportunity for software engineers.
Do you want to know more about key software solutions for electric vehicle charging,
such as high voltage, power electronics, untold stories of global automakers and software innovators,
and the future of electric vehicle charging strategies?
Let's join us in Tech Innovator 14,
Revolutionizing electric vehicle charging through software innovation
by FPT Software, on June 16th. To hear from our leading experts, Dr. Duong Van Nguyen, the head of Panasonic Automotive Systems Europe at Panasonic Automotive EU. PhD Tien Dung, head of Automotive Center of Excellence at FPT Software. PhD Huy Chieu,
Chief Technology Officer at New Electric Vehicle Group,
and former Chief Technology Officer at Vinfast. Register now and get ready to be inspired.
the depths of our oceans, to the heights of space, there are no limits to what we can accomplish when we push past our current boundaries. There is nothing more potent than the will to learn and to share what we know. The future is happening faster than you think. Curious about new tech trends? We're here to help you stay up to date with this fast-changing world. At each live talk, we will discuss different technologies and trends with global experts from countries around the world. Ask your own questions and learn how to get the answers you want to get on the forefront of technology with tech innovators.
Electric vehicle adoption is outperforming all expectations and is now expected to represent over half of U.S. vehicle sales by 2030.
The key link to mass adoption is now software, not hardware or vehicles. From $1 billion in 2021,
electric vehicle charging software is forecast to grow to $25 billion by 2030.
making it one of the fastest growing software sector in the market today, and a huge opportunity for software engineers.
Do you want to know more about key software solutions for electric vehicle charging,
such as high voltage, power electronics, untold stories of global automakers and software innovators,
and the future of electric vehicle charging strategies?
Let's join us in Tech Innovator 14,
Revolutionizing electric vehicle charging through software innovation
by FPT Software on June 16th. To hear from our leading experts, Dr. Duong Nguyen, the head of Panasonic Automotive Systems Europe at Panasonic Automotive EU. PhD Tien, head of Automotive Center of Excellence at FPT Software. PhD Huy Chieu,
Chief Technology Officer at New Electric Vehicle Group,
and former Chief Technology Officer at Vinfast. Register now and get ready to be inspired.
Electric vehicle adoption is outperforming all expectations and is now expected to represent over half of U.S. vehicle sales by 2030.
The key link to mass adoption is now software, not hardware or vehicles. From $1 billion in 2021,
electric vehicle charging software is forecast to grow to $25 billion by 2030,
making it one of the fastest growing software sector in the market today, and a huge opportunity for software engineers.
Do you want to know more about key software solutions for electric vehicle charging,
such as high voltage, power electronics, untold stories of global automakers and software innovators,
and the future of electric vehicle charging strategies?
Let's join us in Tech Innovator 14,
Revolutionizing electric vehicle charging through software innovation
by FPT Software on June 16th. To hear from our leading experts, Dr. Duong Nguyen, the head of Panasonic Automotive Systems Europe at Panasonic Automotive EU. PhD Tien, head of Automotive Center of Excellence at FPT Software. PhD Huy Chieu,
Chief Technology Officer at New Electric Vehicle Group.
and former Chief Technology Officer at Vinfast. Register now and get ready to be inspired.
Welcome everyone to Joytech Innovator 14, Revolutionizing EV Charging through Software Innovation. I'm Joey, the moderator of the webinar, and I am very excited to have all of you joining us today. As the world shifts towards sustainable transportation, software innovation is playing a crucial role in transforming the way we charge electric vehicles. Today, we're going to uncover how software innovation enhances efficiency and revolutionize EV charging. Now, let's take a moment to introduce our panelists. I introduce Dr. Nguyen, Head of ADAS at Panasonic Automotive System Europe, based in Germany. He's also the representative of Panasonic Europe at EU Commission. Dr. Huy Chieu, CTO at New EV Group LLC. And last but not least, Dr. Dung, Head of Center of Excellence at FPT Software. Mr. Dung, Mr. Huy, and Mr. Dung, please unmute your micro and say hi to the audience.
Hi everyone. It's very, very pleasure for me to be on the stage today. Thank you.
Thank you for joining us today. I would like to remind everyone that our talk will have two sections. The first one will be the panel discussion, and the second part will be the Q&A. So please stay tuned. Now let's jump right into our first topic, EV charging stations. To shed light on this matter, I would like to invite three speakers to share their thoughts. I think we can start with Dr. Huy Chieu. Hi, Dr. Huy. What challenge EV OEM has been facing regarding charging station in global scales?
I think from EV charging station perspective, a few issues. Depending on globally or which region, there's the main concern is charging station availability and where the charging stations are located. As you know, a lot of EV customers have what we call, or what many people call, range anxiety. How they can charge, especially in the North American markets where folks travel a long distance. Having the charging stations available in a certain area and where they're strategically located is an issue. Also, like the compatibility, operability of the charging stations with the EV, the integration, some of the payment issues. As we travel, we don't want to wait too long for, availability of charging stations, and also making sure there's a seamless payment integration. I'm sure everybody heard recently, at least in North America, several OEMs joined Tesla in adopting their kind of what they call it, kind of Tesla charging port instead of the CCS1. So that opens up the kind of availability of the Tesla supercharging network, which is the best in at least North America to do that. So, definitely the kind of availability of charging stations is a big issue for OEMs or EV OEMs. But then if we move to different regions, there's different also kind of concerns with the EV OEMs of availability. If you look at even Vietnam, how future OEMs kind of integrate that with the current charging network is going to be a big concern. Some of the kind of forefront developers, if you look at China, they have a lot of availability there. So, that's kind of the main concern right now for EV OEMs, is having the availability of the charging network or EV charging stations.
Thank you for your sharing, Mr. Dung and Mr. Dung. What's your opinion? Do you have any additions?
Yeah, maybe I can start shortly first. That actually one of the main thing is about the standardization. That's, of course, at the end, we don't want to have so many different variants on the markets where if you buy one car and you could not charge it, and you have to find the particular slot for that particular car. And of course, the second point is about the times, because it doesn't make sense to spend hours just to charge the cars. Up to now, even though the supercharge from Tesla is taking like 40 minutes or something, and that is too long for the driver. This is to be crazy if we have a population of the big city and are waiting for every car is 1 hour. That's too much. So timing is a problem, and of course that is where the software will have supposed to manage it and to see how the efficiency and so on. And so that is the points to look at. Yeah.
And I would like to ask one more point that with the demand rising for electric vehicle, for sure the grid in some country for sure need to handle let's say the power demand from electric vehicle charging. Yeah, besides like all the standard different things you mentioned, right? Because we don't want like our vehicle use some charge demo, for example, charging protocol and cannot charge in some charging station with other charging protocol. It should be some challenge for charging.
Thank you for your sharing. And following that, I would love to dive deeper with Dr. Huy Chieu. From your own experiences with OEMs you work with, what the most difficulty when an EV startup enter a new market like US in terms of charging stations?
I guess it kind of bounces off the previous discussion we have about availability. But if you talk about the U.S. In particular, about we just mentioned kind of the standardization, the availability, the vehicle power to grid issues with the U.S. But from a, I guess, EV charging station perspective, I think new OEMs that enter the U.S. market need to kind of build up the charging infrastructure, because having a new brand, for example, launch into the U.S. market, we have to provide the consumers kind of a seamless customer charging and user experience. So working with existing CPOs or charge point operators, the recent, the big concern right now is the recent adaptation of the kind of Tesla charger, where a lot of OEMs are changing. But we see in the last week different kind of CPOs, like charge station kind of manufacturers, also adapt to this upcoming trend. So I think if we look at how and I don't want to revert to always a standard. So if there's a kind of countrywide standard, like how China does it, they have their own standard, then everybody does the same. Then everybody can use the same charging station. But I guess new startups, the big concern from a charging station perspective is kind of that standard or operability, and then also the seamless kind of payment. So using the software, one of the things that's very intriguing is, for example, the customer can pull up the navigation system, and it kind of maps out all the charge point that you can get there, and then reserve the charging station, get there, and have a seamless payment. So all the software that we're talking about here is kind of the key to kind of having the seamless charger experience. So from a hardware perspective, having standard and adaptability to the charging EV network, and then from a software perspective, having kind of all that integration to have a seamless user experience from a charging perspective to go coast to coast.
I see. So moving on to the next questions, I would love to hear all three speaker opinions of what technology innovation that apply in charging station to enhance its efficiency and user experiences. Can Dr. Duong start with this questions?
Yes, I think, yeah, so like we all mentioned about the availability and standardization, but of course that's difficult to talk right now. No? It takes time to do that, but there's something it might be help to understand what is the need, what is the blocking points in the user experience. It's about how to have the ecosystem around it, or how we have such a software, such a management tools and so on, just to, let's say, first to highlight what is the good or no bad things. That's so software is a good thing, and the innovation, it's also possible that I see a lot of direction that people are going. Like if you read the news just yesterday, from Stellantis Genesis that they are going to deploy the patch, so the padding. So it is like the charging pad. So that means it's a wireless charging. Yeah? And of course, it's very slow. It's like 2 hours or 1 or 2 hours compared to the supercharge from Tesla. But that is another innovation they are going to talk about. And of course, there's in some road they also put some wireless charging. So there are a lot of things coming on, and we need to wait and see at the end which one survives.
I see. Thank you for your sharing. Dr. Dung, can you input some more insights from your end?
Yeah, sure. So talking about efficiency, I think we talk about two things. The first one is about the design of system, and second one is about the utilization of the charging station, right? How we can use charging station in a effective way. So if we talk about the design, for sure, we need to design the system for charging station and so for vehicle in effective way, right? So if we involve hardware design, also software design. So first one, we need to do to design the system with less losses and with high efficiency. Second one is like maybe we heard about like IoT in charging infrastructure, right? It means that the charging point can communicate with the grid, communicate with EV electric vehicle, communicate with user or let's say EV owner through the application on their smartphone. So it means that we can share the charging station in very effective way. For example, right, the user A just want to charge the vehicle in 5 minutes, and then user B need to charge the vehicle more, something like this. So by using IoT, we can better balance the charging resources between the charging station. So by doing it, we can improve the efficiency of charging infrastructure.
Thank you. Dr. Huy Chieu, do you have any more comments on that question?
Yeah, I think from a couple of things. From a hardware perspective, I meant like Dr. Dung said, some of the heat losses, right? So, the onboard charger efficiency, from a hardware perspective, adding liquid cooling, the cable design, from that it's the hardware perspective. But from a software perspective, one thing to add on top of the IoT is the very much talked about subject of AI now. So using AI or artificial intelligence to predict when customers' demand of the charging station increases, when the reduced electricity cost comes in play, so they can draw in the electricity at a lower rate and disperse it at a more efficient manner. Looking at solar panels, and then also the last thing is like the user experience. As users go into charging stations, how they can value or utilize that 15-20 minutes or half hour that the consumer is there. So you'll see a lot of charging stations, at least in North America side, and rolling out to Europe, having a lot of the screens, displays to kind of improve the experience there, and then also generate revenue streams with e-commerce. So looking at all the AI technology and predictive, cater to what that person wants. If they're interested in, for example, I don't know, a new motorcycle or a new bike, then display advertisement for that. So I think from a software perspective, AI will generate a lot of new innovations in the EV charging space, station space.
Fantastic. Since we have Dr. Dung here, an expert in ADAS, there one specific question for you. Are there any relationship between ADAS and EV charging station, or in another words, that how ADAS indirect impacts on EV charging stations?
Yeah, so actually it's very much related to each other when we go to the bigger scale. Yeah? Now we don't see so much. Now manually we have few cars that go and they charges and nobody bother others, so we don't see the impact from that solar. But imagine that when the number EV really increase, then you can imagine you have a huge area just for charging station. It's really huge, and then it's not easy just to find which one is going to available. So the people cannot just go around. So such communication is one point, and even the system should even maybe it can run by its own. Like if you see the latest one release last 5 months from NIO, that the car is run by its own. and it go, and of course it can charge. In case of Neo, they swap. It's a little bit more complicated. So if it's swapping, then the ADAS is there because it's like a robot. It need to know where to park exactly in the location to charging. But I think the other car can shoot even in the style of Tesla and the other. It's also possible that the path planning to give the most efficient way to reach to the destination should be there, and the guidelines for the drivers, and that it give the whole information about the charging station. It can be very big areas, and for another way that we never know that which one is the winner at the end. So if the guy, for example, if the guy using the wireless charging, if they have a big volume, then it's almost like you have to use the ADAS function to park the car exactly in that. So you don't want to have everybody to drive the car to park exactly on that path. And that is a bit difficult for the driver. So, and if it would be the case, then the ADAS would contribute hugely for that part of the charging. Yeah.
I see.
Thank you.
I see. Thank you for your input. So now let's move closer to the
sorry, sorry. I just want to add one more point about ADAS. It's okay. It's not like a very clear relationship, but if we're talking about ADAS and the hardware in vehicle, so now Huy Chieu, we know better than me now, right? With the trending that for electric vehicle design, people usually combine some like high voltage component together. For example, we have OBC is onboard charger and DC-DC converter. Before it was like two separate components, but now the trending need to combine two components in one box, like we call two in one. So it means that we have in one box one component we have both function, charging, and also convert high voltage DC right to the low DC for ADAS system. So with the evolution of ADAS, we will have more and more component or consumer of electric by ADAS system. So the DC-DC need to design or develop with higher power. For example, right before the DC-DC converter, we have the power only, let's say, 1.6 kilowatts or 2.5 kilowatt. But now in almost vehicle DC-DC, we have the power of 3 kilowatt. So it because of the more and more racing consumer in ADAS system. So it's one of the relationship I want to share between the ADAS and also the charging, let's say, system in the electric vehicle. Yeah, maybe you can add some more point here from vehicle perspective.
Yeah, I think what you're saying is, I think, some electric vehicle or EV has like 80 ECUs, right? So the trend is to combine a lot of the kind of ECUs together, and that's also the case for some of the in-vehicle charging, to combine different components into one box for many reasons. From the integration perspective, and packaging would be easier, and to be able to design cars that are more space saving and improve safety. So from that perspective, I think from ADAS components, as we have more and more, there's going to be more critical integration to the entire vehicle. But from an EV charging space, I agree that from a wireless charging, if that takes off, and right now obviously it's very in its infancy stage, but if that takes off, the ADAS can guide the car to all the wireless stations. And also, if you think about if you had an app, some people have auto summon app where you can actually pull up your mobile phone and summon the car to you, but you could actually summon the car to the wireless station, so you don't have that downtime. For example, someone pulls out the car, it notifies you, then you say, hey, I have an open space, then you summon the car to the charging station or a wireless charging station. But then, if it's a super fast charge or level 3 charger, you would summon the car and then at least occupy the space and then go there and charge the car. So there are some kind of unique features with ADAS that you can integrate into EV charging, particularly improving the efficiency and removing the downtime of the EV charger by putting your car there self-guided to the charging station. So.
Thank you. I think that pretty much covered the charging station section. Now we can move closer to the vehicle itself. When EV OEM building their in-car charging systems, what the most challenge that they have faced? My three speakers can share your insight to the audience. I think we can start with Dr. Dung.
Yes, so I think let's start with Huy Chieu because in vehicle, right? Huy Chieu is the best expert here. Huy Chieu, can you share a bit about the OBC, about charger system, and so on, packaging, safety related to the vehicle?
Yeah, so it kind of bounces off what we just talked about, more of the integration of the different components into one. So from a kind of charging or onboard charger, a couple things. Number one is right now, the integration and packaging is very critical. You know, with I just mentioned that some vehicles can have over 80 ECUs. So one thing is to kind of integrate and package the onboard charger and the other high voltage electronics in a manner that kind of enables a package savings or space savings configuration, and also we have to kind of look at safety. So for example, we package things in a certain way that we think works, and we use CAE and other methods to kind of simulate crash testing to make sure in a crash some of the high voltage doesn't get damaged and that sort of stuff. So number one is package integration, and the fact that or the trend of combining more ECUs into one or more components into one in a box kind of helps that cause, to kind of make sure that we address the kind of physical portion of it. OBC is obviously, or onboard charger, it converts the AC to DC. So, that's the bottleneck for kind of level 2 charging, right? You could have for example, 50 kilowatt kind of AC coming in, but if your onboard charger is only capped at 11 kilowatt or 7.7 kilowatt, then you're limited by that bottleneck, right? So more efficiency in the OBC, 22 kilowatt max right now to kind of leverage the entire bandwidth of what is coming in to convert to the battery. So from that perspective, I think a lot of the software has to monitor all that, all the cooling and all the temperature, the battery and the BMS. So all that has to work together very seamlessly to enable a good charging system or onboard charging system on a vehicle. So that the integration or software integration, EE integration is very critical to the entire kind of vehicle architecture. But more importantly, as we move towards a kind of, or everybody's moving towards a software-defined vehicle where, we upgrade the vehicle using software. So the initial setup of the vehicle from a E architecture and a vehicle architecture perspective, that we don't have to go in and upgrade physically the type of hardware and wiring and future upgrades through over there and software upgrades. So that whole integration is the most challenging part for OEM.
Yeah, so talking a little bit about the software development for like electric vehicle and charging onboard charging system as well. So as Nguyen mentioned about the OTA, right, update over the air. Also, we need to develop the software to fulfill the cyber security requirement to make the car safe, right, by cyber attack, and so by some full SAR function. Like let's say we talk about functional safety. So there is so many challenge for the software development, but also there is many innovative way you can use in this process. I also need to develop the software to understand, to communicate with all the charging station, to understand all the charging protocol, right? Like Tesla supercharger or GBT or CHAdeMO or CSS. So we have different kind of charging protocol, and the software need to understand all of the protocol and communicate the vehicle with the charging station.
I see. It's quite complicated for building the in-car charging systems. One more question regarding to the in-car charging system. How does the in-car charging system optimize charging efficiency and minimize charging times? Like how the technology innovation help that to minimize the charging times and the charging efficiency? Can Dr. Dung share with that?
Yeah, it's what we were talking about, right? First one is efficiency is design. So we talked about this already. About the charging time, so we have like different level of charging power. I think we did mention, right, with AC charging, we have kind of maximum power now is 22 kilowatt. So we have DC charging. So with more power, right? Even that with more power, you have less charging time. So we have like the slow DC charging with the power under 50 kilowatt, if I'm not wrong. And then we have, let's say, fast charging with the power is about 150 kilowatt up to 350 kilowatt. And then we have super fast charging, right? With the power is more than 350. So the point here is that with the more charging power, you have the less time to charge the vehicle. But when we increase the charging power, we face one issue with the heat, okay, with the heat of the charging system. So we need design so the cooling system can handle the heat capacity, let's say, ejection, right, during the charging process. So it is on the challenge we need to face when design the vehicle, and so the charging station for the charging process.
I see. So following that, Dr. Dung, what are the main components and subsystem involved in high voltage system of an electric vehicle, and how do they work together to facilitate their vehicle operations?
Yeah, so I would ask also Huy know
Yep. So
very well
can
about
we share your
electric
insights
vehicle,
for that questions?
Yep.
Yeah, I mean, I thought you had a slide, or you want to show the slide or the PowerPoint that you showed, because that might help a lot. Otherwise, we might be here talking about yeah.
Okay, good. So let me share on slide is some like a picture. Creating this one. Yeah, let me share quickly. Yeah, can you see my screen?
Yes,
Yeah, thank you. Can you see my screen? Can you start from this one?
Yeah, I mean, yeah. So this is the general layout of EV onboard charging. So you get the charging inlet that we talked about. Different types of standards, different around the world. So that goes into the onboard charger, DC converter. So the onboard charger, actually, the reason why we need onboard charger is to convert the AC, the alternating current to direct current, because the battery only can take the direct current. So that is required to kind of convert the AC to DC. Now, since we're talking about EV charging stations, DC, at least super fast charge, takes the kind of onboard charger or the efficiency of that and puts it into the charging station. So the charging station will take actually that kind of conversion. So it's actually DC to DC. So when you have DC to DC, then actually when you plug it to a super fast charge out there, that's why it's so fast, that it provides the energy directly to the battery. In this case, we need an onboard charger to convert it, and a DC converter to kind of control the different voltages within the system or the entire vehicle, because there's different, obviously, voltage requirements throughout the system. So that kind of regulates all the DC. It doesn't show here, but obviously the traction battery, the battery that kind of stores energy, and then you need a BMS or kind of battery management system to kind of look at the temperature of the battery, what the capacity is, what the charging is. That kind of works with the different onboard charger and communicates also to the charging station on where things are. One thing to note, that the charging speed is usually higher, from 0 to 50% state of charge. So the charging speed is a lot higher. But if you can think of a bucket, right? So when you fill in water with a bucket, you can turn on the hose and fill up the bucket very quickly. But when you reach to the top, you can't have too much water. You got to drip it in. So the BMS and works with various components to kind of manage that charging. And obviously you have the inverter and electric motor that powers the, whether it's front wheel drive, rear wheel drive. But this is, I guess, the general overview. We don't want to, because this is software, but we don't want to spend too much time. But from a software perspective, all these kind of have to work seamlessly together with all the ECUs in the vehicle and the charging stations. So there's communication. If you look at actually the charging inlet, there are different control points to talk with the the BMS and talk with the charging station itself. So that's where all the software integration comes into play with the entire architecture.
I see. Thank you, Huy. Dung, do you have any more comments or additions on that?
Yeah, just one comment that you did mention before, like if related to ADAS system, so anh Dung, right, ADAS system we use the power from this DC converter, right? Yeah, because ADAS is like low voltage system, we don't high voltage, so the DC converter will convert energy from the battery and then convert it to a low voltage power source for the ADAS system somewhere here. And the software always play a very important role to communicate and to manage all of this process on our vehicle.
Yes.
I would expect for the question later on from the audience, that's why don't we increase the voltage, not why we are staying with 12 and why not to go higher. No? That would be interesting, but I'm not sure if we would have time to discuss that topic, but let's see.
Yes. Okay, so thank you guys. Before we conclude this panel discussion, we're gonna move on to the Q&A sections. So we have received more than 100 questions sent to you guys from our participants, and we have chose the best one for the Q&As. So now let's start with the question number one. What do you think about the most challenges when it comes to EV charging station in developing countries in general, or in Vietnam in specific? I think for this question, maybe Dr. Huy Chieu can help out with that. So we mentioned about their state already, and right now we focus on the developing countries.
Yeah, I think from a developing country is to power the EV stations, you need actual power, right? So the kind of power grid infrastructure, and where these kind of EV stations or super fast charge stations or level 3 stations are places along highways. So if you look at a developing country, is the road infrastructure even there? Like, meaning, is the power infrastructure even there? The second one is the kind of like the vehicle grid interoperability. Can the vehicle can it talk to the grid? Is the grid capable? I think even Vietnam right now is experiencing rolling blackouts, right? So there's, from that perspective, is developing countries able to supply the power source along the highways, along the road, to kind of do the infrastructure. So those kind of are the kind of main issues with the power related to while you're charging. So even if you had an EV station strategically placed and you have an issue with the grid and it shuts off, and if it shuts off, then you got to reset everything. So I think from a developing country, the infrastructure there is a big concern. One thing is policy, right? The policy of the governments of developing countries, what the priorities are. A lot of countries that have quickly implemented EV charging station was because of a couple of things. Number one is the government incentives. The government provides a lot of incentive because EV charging stations are very expensive. So government providing incentives, also, the cost of power, to kind of encourage folks to adapt EV. If you don't have enough EV adoption into the developing countries, then implementing a big EV charging infrastructure is not kind of value add, or not the business case isn't there. So having the government and policy push the EV rollout, and also incentives for setting up the infrastructure and building the grid is going to be a big challenge for the developing countries.
Thank you. So it's like Dr. Dung, do you have any more comment on it, or we can moving on with the next questions?
Yeah, I think Huy Chieu already mentioned the challenge for development country, because even important, I think, is a question need to be resolved at the bigger scale, right? At the government scale. Yeah, like, and we said that government maybe need to provide some incentive for private company or organization want to develop or invest to the charging infrastructure. And I think also one more important that it's something like we need a higher demand of electric vehicle in some country. So when the private company sees interest in developing the infrastructure to let's say to fulfill the demand from electric vehicle charging, so we will attract more and more company to invest into the charging infrastructure. I don't think that to build infrastructure is the work or the task of one company, one single company. It is the task of the whole government, the whole country together. And it is the attractive business, but it's not easy because of I know like in US, right? Some big company, charging companies such as Checkpoint or EVgo, until now they still don't have profit. So it is a big challenge to invest on this one. But we hope in the future, right? We have more and more EV demand. Yes, the charging infrastructure will really provide the profit for the company, and more company will involve in and invest in the charging infrastructure. One more thing I think is that as we were talking at the beginning of the webinar, is to standardize the charging protocol. By doing that, we can, let's say, better utilize the using of charging station. Something like, we can imagine the situation maybe very similar to the smartphone charging, right? We have different kind of charging, such as USB-C, USB-A, Lightning. So if we can standardize just one kind of charging like USB-C, so it will be more effective for using those charging station, something like this.
I see. Thank you, Nguyen and Huy. So one question for Nguyen. So from the market perspective, what are the key challenges and opportunity associated with integrating ADAS technology into EV charging infrastructure?
That's a difficult question.
Yeah.
So okay, so let's say it's still up to the points of when we have let's say the quantity from the EV cars. So up to now, let's say the ADAS is not designed for the EV. Let's say it designed for every cars, and for EV car actually it's much easier. So for a normal car, you have like some thousand of components that you have to handle. In the EV car, you simply have battery and motor, and of course something around, but it's like 1,000 times less complicated, and the precision is much higher because you know exactly what you want to turn the motor to be on. So that's why it's up to now the way of the ADAS doing is still like very generic, and it's not really specified or designed for the EV specifically. And when it go to that manners of the EV, then I think the ADAS can simply contribute a lot in terms of, let's say, the efficiency in terms of how the system to be designed, because we are talking about the software-defined vehicles. And in the ADAS, let's say we have a pretty cool, let's say already the expectation for the zone domain controls and what kind of distributions of the hardware, so that it can be scaled from level 2, 3, 4, 5. And that's fully, or it can be easily integrated with the EV when it comes to the picture. So I think that there's a lot of the thing to be done in ADAS when it comes to EV car. I saw the EQS that we test last month, the newest version from Daimler, and the Neo and Tesla with the Tesla, the latest version, and we see that there's a lot of room to improve the ADAS. They're fairly up to now. It's just purely not really designed for the EV car, but it worked pretty well because it's much simpler and more accuracy to be realized in the EV car, or of course it can have also for the design of the whole vehicle architecture.
Interesting. Thank you, Nguyen, a lot for the very detailed answer. Right now we moving on to the next question for Dung. So how do you anticipate the needs of highly skilled high voltage and power electronics engineer in worldwide scale? And as a technology provider, how do API software prepare for that?
Oh, it's a very good question, Joe. So yes, so power electronic, very simple. Let's say very it's not new terminology in the industry. But before we already have power electronic in industry, right? But for design, develop the bigger component, for example, for charging the airplane. So we need very big box to charge the airplane. But since the electric vehicle got the evolution, or let's say the high demand, so it requires to compress, let's say, to design the smaller component, for example, OBC, to put it to the vehicle. So the power electronic just become to another challenge of development that you need to develop, okay, high voltage system, a power system, but very compact side. And I can share one story from MPD that we just we prepare for that, and currently we have some project working in OBC, DC development for a big Taiwan in US. So as the first time, right, to find resources in power electronic who have experience working in power electronic system for a vehicle was not easy. Yeah. Also, we were very surprised about this at the beginning because let's say this power electronic component for electric vehicle just started about 10 years ago, something like that, 50 years ago. So to find good people is not easy. But yeah, we could find some, we get good people team, power electronic expert came from Korea, Taiwan, US, Europe, and now we have a team who is ready and can develop such kind of component, for example, DC.
I see.
And we're working on this.
Thank you, Nguyen. Okay, so I also received another question from Mr. Nguyen, researcher at UCLA in California. He asked a question like this: How would power electronics design and control system play a part in the software innovation of EV charging? I believe for this question, Dr. Dung and Dr. Huy can help out with that. I can repeat the questions. How good power electronic design and control system play a part? Hello?
Yeah, hello, can you hear me?
Yep.
Hello?
Yep, yeah. I can hear you.
Yeah, I guess building onto that, I think building onto that, I think the question is about the future kind of power electronics in the charging space. If we look at cost effectiveness, because everybody's going to be in the business to make a profit, right? Because the cost effectiveness, power electronics is kind of the driver to reduce cost of EV charging, right? Because it's minimizing the kind of waste and kind of improving all the charging time. So from that perspective, if we look at how look at power electronics is, look at kind of advancement and innovation to look at beyond the next, 2-3 years, but look at more of a 5 to 10 year horizon to see how that they can, I guess, launch something that's from a hardware perspective, more sustainable, because it's just like with any electronics right now, we see like a 2-3 year cycle of the, of obsolescence, meaning things come into play. And then 2-3 years later, you look at your phone, it's already obsolete, right? So to look at how we can scale the power electronics from that perspective, how it plays a part on software innovation is, we mentioned it a few times already in this forum, is kind of the SDV or software defined vehicle. What, software defined vehicle is basically the ability to upgrade the car throughout its lifetime, right? And cars, I think, especially EVs, the lifetime of a vehicle can be prolonged because EVs can last much longer because of the reduction of kind of the ICE or internal combustion engine and other moving parts. So it lasts longer. So back to one of the comments I made earlier is looking into the kind of architecture from an EE perspective or centralized architecture, and having it be upgradable, updated with new kind of applications to improve functions. If we look at even ADAS, when you roll something out, it could be level 2, level 3, but the hardware is there, right? So once you get level 3+ or beyond, then you can kind of roll out additional functions. So, as we test these new innovations from a software perspective and roll it out, to have power electronics kind of be at the forefront, because without the power electronics and hardware, the software doesn't really mean anything, meaning we have to have a capable hardware and architecture setup in order to have a software that we can upgrade the car throughout its lifetime. You know, that's the beauty of having an EV, right? We can always update software, we can make it better. We find some bugs or some issues with the car, we, you know, test it, and then we can just roll it out to over there to all the customers. We don't need to bring it in and change something and replace something. We can just do it through software. So from that perspective, I think the power electronics design and the kind of control system does play a very important part, a critical part into software innovation, because they go hand in hand. Without the hardware, we cannot implement software that can upgrade and kind of improve the EV charging experience.
Thank you, Huy. I believe we haven't mentioned about the security yet in EV charging, and right now we got one question regarding to the security. So, are there any security measures in place to protect EV charging software and user data? So, I believe for this question, Huy can answer again, and then maybe like some comment from Dung and Dung.
Yeah, I think cybersecurity, there's certain cybersecurity standards in place right now that all OEMs have to meet, right? They have to protect some of the data, the consumer privacy. Each region has different requirements. So for example, Europe might have a different type of data privacy protection and stuff like that. So as we look at that, I think there are minimum standards that you have to meet from a cybersecurity perspective. I think, and I recently talked to some of the EV charging companies. And you know, one of the biggest concerns is cybersecurity and how they need to prevent or protect from that. You know, one of the things is payments, right? You know, when customers go to the payment, you know, having their credit card or information stolen. So that's a big concern. One of the kind of up and coming is to use, like, for example, one software is like using blockchain technology to improve the cybersecurity of EV charging. But you know, all that I guess is very critical right now from a cybersecurity perspective, that many EV charging companies as well as OEMs are kind of struggling to meet as standards get rolled out and become more stringent. Then that kind of whole area has a big team working on it right now in terms of how to meet that kind of cybersecurity or data protection act. So I think that's going to be driven from two fronts. Number one is the OEM's internal the standards and what they believe is kind of critical. And more importantly is the government and the regulatory authorities that implement specific cybersecurity requirements and data protection protocols. So that will drive kind of the requirements from a software and cybersecurity perspective.
I see. Thank you, Huy Chieu. So I think we're gonna have maybe two last questions, and then we can moving on. So the next question gonna be: the EV charging software offer real-time monitoring and reporting capabilities? I think for this question, maybe go to Dung, or like, hi, Dr. Dung.
Sorry, can you repeat again the question?
Okay, so does EV charging software offer real-time monitoring and reporting capabilities? I think it's like more vehicles, so maybe, but Dr. Dung and Dr. Huy can help out with that.
I think yes, right? So on the system, we have the real-time monitoring charging process. We're talking about charging management. So yeah, on system, on the software, the hardware system, we need to monitor the process. To detect also if any let's say incident or any error happen in this process, and provide the countermeasure for the safety purpose, right? So for example, when the vehicle plug into the charging, the software or the vehicle need to monitor the temperature, the battery, for example, and we stop charging when the temperature of the battery increase to some limit, to protect the battery on the electric vehicle for safety purpose. Yeah, I think sure. Yeah.
I see. Huy, do you have any more addition on the questions? Are we good to go?
No, I think yeah. I meant if you look at kind of the real-time monitoring, I meant The other part I would add is kind of the mobile apps, right? Meaning a lot of the OEMs right now they have a mobile app for the phone where they can mount it to the phone, send all the data to, talk with the vehicle, to look at what the battery temperature is, like, what the charge rate is and all that stuff. So from that perspective, it's always real time. I mean, it has to be real time. There is no other way to do that. And then, as the CPOs or charge port operators work with the OEMs, from a real-time perspective, is looking at the availability of the charging stations, if the charging station is up. Many EV owners experience a bad charging experience where they say a charger is open, like, it's green, nobody's there. They go there, nobody's there, but it doesn't work, right? So, real-time monitoring is a critical kind of requirement from a user experience perspective to allow for seamless EV charging. So that is a must requirement for that. And then we mentioned about using AI, so some of the new development is using the AI to predict a lot of the consumer behavior that might not be real time, but it supplements what the behavior would be to kind of even enhance a better charging experience than what is actually data provided, because it kind of predicts what the behavior would be. So the short answer is yes, it is all real time.
I see. Thank you. So I think this is going to be the very last questions. What are some of the software-related challenges that arise when implementing smart charging algorithms within the AutoSAR framework, and how are these challenges being addressed by the industry?
I think the question a little bit more for the software. So let's see. I will try to answer this one based on my knowledge. For sure, there's a lot of challenges when we're going to develop a software like for smart charging system, right? And we're discussing first one, the software need to manage the charging process, or let's say to find an optimized way to control the charging process to make sure that we can charge the battery effectively. Second one, right? The software need to let's say communicate and recognize all the charging protocol. I mean that it will recognize, right, when we plug into ChargeMO system to Tesla supercharger system and so on. It need to communicate, understand, connect the vehicle with the charging station, and the software also need to be fulfill like cybersecurity requirement that we did mention about, not only for charging but for the whole software system of the vehicle, right? And also the FUSA is a functional safety, like to make sure that we are going to have the functional of the vehicle working well. And I think the last point is the OTA update capability. Now for the vehicle, right, all the software system need to be available to update, let's say over the air. Okay, for the firmware, also for software, all we need to be updated. Even we also can say about the software maintenance over the air. I mean that based on some analysis or diagnostic from vehicle, the company OEM just need to update the software, right, to resolve the problem. So let's say I think it's the main challenge for the software development. And now AutoSAR it become a standard, and all the OEM try to develop based on AutoSAR platform. And now if we talk about AutoSAR, right, we talk about the modularity of the system. So we try to develop a platform and then adapt a different, let's say, vehicle to this platform to fulfill all the above requirements that I did mention about previously.
Okay, thank you, Dr. Dung. Dr. Dung, do you have any more comments or any addition on the questions?
Yeah, actually, it's a common problem or the common challenge for all kind of software, including the charging software. That since it is defined as a software in vehicle, it has to fulfill all the, let's say, the compliance. So that is the difficult or the challenge part, because it's to fulfill all of the regulations like the ISO 26262 and all kind of the FUSA, and now we have a cybersecurity. Even though the cybersecurity guideline is not so much, let's say, available now, the UNC is still working on that, but it is coming soon. That means you can imagine that the double work is going to happen now. So that is for sure. It's just challenging, and of course, like Dr. Dung just said, that is since we have to update over the air, then I think it's more difficult when you touch to the EU part, the European part, than the US part, because the EU, they usually make a joke that EU is like safety first. Meanwhile, US is safety last. It's just a joke, but it's real. That in order to launch the car in EU, you have to prove that the car is safe, and you need to prove the test. In the US, it's also have the same regulation, but it's like it can be proven. So you release the software, you prove it works. If anything happens, you go to the court and you can defend it. But in EU, it's not possible like that. In EU, you have to pass the test first, and if anything it's wrong, then they might ban the car forever. For example, if Tesla opened the autopilot in Europe, maybe the company will be banned forever in Europe if any accident happens. So that is kind of slightly different, and of course this is challenge when we go to the EV charging, because this first it's new, no? It's not something like existing the standard protocol. That we have the standard protocol, but let's say still the EV charging is quite a new thing for the car with a high power, and of course that's the guideline is still very abstract. That we have, of course, we have to fulfill all the compliance, but it's still quite abstract, and we need to really to work and to see how the reaction from the regulation coming out in a couple of years.
I see. Thank you, Nguyen, for very insightful answer. And I believe that ended our webinar. On behalf of FPT Software, thank you all for taking the time your busy schedule to join us here today. And have a nice evening in Vietnam, and have a good day in Europe and the States. And your continued support is a huge motivator for us. Thank you again, and see you in the next episode of Tech Innovator Series.
Thanks a lot, people.
Yeah.
Thanks
Thank you a lot.
again, anh Dương, anh Huy, and anh Dũng.
Thank you, Joe. Thank you, Nguyen. Thank you, Angel. Thank you, everyone. Glad to enjoy.